Hi, Algebra students. These are your notes on section 5.6, graphing a linear inequality in two variables. So this is the point where we take kind of a turn in chapter 5. So far, we've been working really hard on understanding systems of linear equations, and now we're going to be looking at inequalities. So this is also something that is brand new to you this year, so please pay attention and take some good notes. We're going to start off by covering some vocabulary. Our first definition today is the word solution. So just like as you see here, a solution of a linear inequality in two variables is any ordered pair that makes the inequality true. So this is very similar to when working with an equation or a system of equations. The only difference is that with a system of equations, you have one specific point that can be the solution to that system of linear equations. With an inequality, you can actually have an infinite number of solutions. That's our word that goes here. And we'll talk about this a little bit more as we work through this lesson. But because we have an infinite number of solutions, we have to show a picture of the graph as our solution set. So let's go ahead and get started. We're going to start again by going back to that vocabulary word solution. How do we know if something is a solution to the inequality? Well, just like with an equation, you have to plug it in and you test it. So remember, ordered pairs come in the form of x comma y. So if I want to know if -4, -1 is a solution, I plug -4 in place of x, and I plug -1 in place of y, and then I'm going to see if it creates a true statement. Okay, so I need to know, does 5 times -4 minus 2 times -1, is that less than or equal to -1? So it's just about using order of operations and crunching some numbers. So let's do our math here. This would give me -20. A negative times a negative is a +2. And it says less than or equal to -1. -20 plus 2 is -18. -18 is less than or equal to -1 is a true statement. Therefore, I would say yes, or it is a solution, however you want to say that. So yes, solution. Okay, so that means -4, -1 is a solution to this inequality. But again, just remember that is one possible solution. There are really an infinite number of solutions that may end up satisfying that particular inequality. Let's go to number 2. And this time we're going to test the point 5, -7. I would encourage you for this one to pause your video and go ahead and work through this on your own, and then come back now that I've explained how to do it and check your answer. But I'm going to go ahead and keep talking. So we're going to put 5 in place of x and -7 in place of y. So we're multiplying -2 times 5, which gives me -10. And we're subtracting 3 times -7, so that gives me a +21. And I want to know, is that less than 15? So let's check my math here. I believe that's 11 is less than 15, which again, it just so happens this one is also a true statement. So I would say yes, that one is a solution. So just remember, anytime it makes a false statement, then that point is not a solution of the inequality. And even though I said you can have an infinite number of solutions, you will also have points that are not solutions of the inequality. I also want to point out that with inequalities, let's say you have, you solve the problem, you're testing a point, and you get something like this, where it says 18 is less than 18. In this case, that is a false statement. A number is not less than itself. So that's a no. But let's say you end up with something like 18 is less than or equal to 18. That is actually a true statement. So then the point would be a solution to the inequality. So just be careful, make sure you're paying close attention to your inequality symbols. All right, so remember we said in order to determine the number of solutions, we're going to be using a graph. So in the second part, this is all about how we graph a linear inequality. So first of all, it says make sure the inequality is written in slope-intercept form, and that's because we're going to be graphing lines. So we want to be able to clearly see the slope and the y-intercept, and as we explained in number 2, that's what you're going to use to graph your line. Is you're first going to plot your y-intercept, use your slope to find other points on the line, and then from there, we're going to decide, just like we explained in number 3, what kind of line we want for our boundary line. Our boundary line is what separates the two halves of the coordinate plane. So if your symbol is greater than or equal to or less than or equal to, then you are going to draw a solid boundary line. If your symbol is less than or greater than, so no equal to portion in there, then we're going to draw a dashed line. So the solid line is going to indicate that the solution could be part of that line. The solution could fall on the line. When we draw a dashed line, that is actually going to indicate that the solution can be very, very close to that line, but it can't fall exactly on the line. Okay, so after you draw your line, the next part is to do your shading. So we have to shade the solution set, and there are 2 methods that I gave you. The first one is 100% foolproof. So I said if you use the test point 0, 0, and you plug that into the inequality, just like we did up here, if it creates a true statement, then you shade the half plane that contains that point. If it is not a solution, then you shade the opposite half plane. The only time you can't use 0, 0 is if 0, 0 falls on the line. Then you want to choose some other point. The reason we're choosing 0, 0 is because it's very easy to do the math. Okay, as you're working through, method 2 is really what I call kind of the common sense method. So if your symbol is greater than or greater than equal to, then you shade the half plane that is, well, let me get my pen back here. Shade the half plane that is above or to the right of the line, of that boundary line. If it is less than or equal to, then you shade the half plane that is to the left or below the boundary line. So again, think common sense. Where do numbers fall that are bigger than other numbers? Above that line, above. So, think about like which direction positives and negatives go on the number line. Okay, but again, checking it with your test point is always a foolproof method as well. So I'll talk through that as we look at our first 2 examples. So I know the very first thing I told you to do was to change equations into slope-intercept form, but to be completely honest with you, if I have equation like number 1 that's in standard form and I can easily see x and y intercepts, I am going to graph using those because I think it's easier. So in number 1, when I set y equal to 0, x is -4. So I'm going to plot a point there. When I set x equal to 0, y is -4. So I will plot a point there. The second thing I'm going to do is look at my inequality symbol. It says less than or equal to. So because the equal to is part of the inequality symbol, I am going to use a solid line as my boundary line. So I'm using my line tool. I'm going to draw in a neat line through those 2 points. Okay, and then we need to talk about shading. The next thing I do is shade. So I need to decide, do I shade above the line or below the line? And again, using my common sense method, I would say that the values of x and y that are less than -4 are going to fall below the line. So I would shade as neatly as possible below the line here, everything below the line. Make sure you can see the points on your line. Make sure your line extends across the coordinate plane. Make sure I can clearly see which half of the coordinate plane that you are shading. All right, and I will go ahead and model for you if I'm using 0, 0 as my test point, which I can because that's right here and it's not part of my line. So if I use my test 0, 0, and I plug 0 in place of x and 0 in place of y, I want to know, is 0 less than or equal to -4? And that is false. 0 is not less than or equal to -4, so that means it is not part of the shaded area. So again, shade the opposite plane or the opposite part that doesn't contain that point. Okay, we're going to go ahead and move on to number 2. And in number 2, I am going to follow the directions that I gave you, which is to change this one into slope-intercept form. So the first thing that I'm going to do is subtract x from both sides. So my equation would say -2y is less than -x. If you want to write -x plus 0, you can write -x plus 0. It's not necessary to do so. To isolate y, I'm going to divide both sides by -2. Oh my goodness, I almost would have forgot this. Remember, when we work with inequalities, when you multiply or divide by a negative number, you must change the direction of the sign. So the less than symbol now becomes greater than. And then over here, look at your sign work, and negative divided by negative is a positive, and I write that when, instead of saying x over 2, I write that as 1/2 x. So y is going to be greater than 1/2 x. So I'm going to go ahead and graph this line. So first of all, just to keep in mind, remember this time my y-intercept, it's not there, or again, it's 0. So I plot that. My slope is 1/2, so up 1 over 2, up 1 over 2, or you can go down 1, back 2, down 1, back 2. I like to draw as many points as I can, especially this time because I'm not going to be able to use my line tool because I need a dashed line because I don't have that. It's not greater than or equal or less than or equal to. It's just greater than. So I need a dashed line here. So drawing lots of points helps me get this line nice and neat. I'm going to pop some arrows on both ends. And then my answer says I want all the values that are greater than 1/2 x. So greater than everything on that line is at the top of my graph. So all the values of y greater than what's on that line fall up here. And again, I just to prove that this is correct, I'm going to show you the test point. Let's go ahead and test 0, 0 in our original equation. So when x is 0, it says 0 minus 2 times 0. Oh, wait, I'm going to back up just a minute and correct myself. I cannot use 0, 0 as a test point because it falls on my line. So I got to pick a different point. So let's use, how about the point, how about this point, 1, -2, this point here. I'm going to test this point. So we're going to use 1, -2 as our test point. So when x is 1 and y is -2, I want to know is 1 minus 2 times -2, come on, there we go, is that less than 0? Okay, so this becomes 1 plus 2, which is 3. 3 is not less than 0, so it means that point should not be part of my solution set. So it looks like I've shaded the correct area of my graph. Okay. We will definitely review that in class with you. I know we only solved a couple of those, but we are going to look at one more graph in the real life application. So this time we're showing you how you can take what we've worked on and apply this to a real life situation. And we'll also make a graph with this one, so that will help. So it says you can spend at most $12 on tomatoes and red peppers for salsa. Red peppers are $4 per pound. Tomatoes are $3 per pound. They want us to write and graph an inequality that represents the amount of red peppers and tomatoes that you can buy. So I know we've been working a lot on solving real world problems. So remember, the first thing we always do is start with a variable statement. I like meaningful variables. So instead of using x and y, I'm going to use r and t. Whoops, I don't know why I wrote r and t. So I'm going to say, well, let's do this. We'll use x and y. That way you can see it clearly on your coordinate plane. So we'll say x equals the amount of red peppers. And then we'll let y equal the amount of tomatoes. Just don't want to confuse you on the graph. Okay, so red peppers are $4 per pound, so 2x, and tomatoes are $3 per pound plus 3y, and it says we're going to spend at most $12. So I would say less than or equal to means at most 12. Okay, and again, you can take this inequality and you can change it into slope-intercept form. I think this is a great one to use x and y intercepts because 2 and 3 are both factors of 12. So when y is 0, x is going to equal 6 because 2 times 6 is 12. When x is 0, y is going to equal 4 because 3 times 4 is 12. Okay, and those of you that are changing this to slope-intercept, please feel free to do that method and you can check my work. So 4, 5, 6 on my x-axis is all the way over here at the end, and then we're going to go up to 4 on the y-axis, and because it's less than or equal to, at most $12. I think we're good. I was checking my inequality symbol. So solid line when we graph. So I'm going to pick up my line tool and I'm going to graph that line between those 2 points. Okay, and in less than or equal to means I want all the values that fall below the line. Okay, and then it says identify and interpret at least 2 solutions of the inequality. So what I want to do is go through and look in that shaded area. So for example, here's a point and here's a point that fall in that inequality. So 2, 1 is a solution and 1, 2 is a solution. So you can have 2 pounds of peppers and 1 pound of tomatoes, or you can have 1 pound tomatoes, whoops, I'm sorry, I said that backwards, 1 pound of peppers and then 2 pounds of tomatoes. Okay, notice I didn't choose anything over in this section here, and that's because we're talking about a real-life application problem, and I can't have a negative amount of peppers or a negative amount of tomatoes. So really anything that falls within this little triangular region right here is part of my solution set for this real-life application problem. All right, my friends, that is it for section 5.6. I hope you understood everything. Please take any questions you have back to class with you tomorrow. Have a great night.